Mark, you are the Chief Operating Officer of
accidentally promoted to CEO originally there, but testing, all good. Fantastic. Thank you for having me today. I'm Mark Ramsey, the Chief Operating Officer for Space Machines Company, and we are an in-space transport and logistics company, and I'll explain what that means in a minute. Space Machines itself was founded in 2019. We're a company of about 30 people at the moment. I think we've just cracked over 30 people this week. And we've got 2 launches in the next 12 months, one on our friends at Gilmore here and one on SpaceX, because everyone's doing everything. We are based here in Sydney. We've got our main manufacturer assembly integration test facility. We've got an office in Adelaide, and we have a team in Bangalore and India as well. And so what are we trying to solve? We're really a transportation and logistics company at heart. So we'll talk about it a bit, but most people who want to move packages around the world, you know, they don't go to ship companies or aircraft companies, they go to logistics companies who move their packages. So what we're trying to solve is to really focus on the in-space transport. So once you get there on the hypersonic rocket, then what are you going to do? Where are you going to go? So you're in low Earth orbit, where do we go and how do we do that cost effectively? I guess just looking at a bit of a genesis of how the company thinks about things, we looked back at sort of logistics models across the last 100, 200 years, and with each kind of major technological leap, you know, from rail and road to large ships to aircraft, we've seen them unlock tremendous economic value by the advent of these sort of major things, and we think space is next. And what I mean by that is, you know, by the train and railroad in the US, you know, they basically unlocked the Western United States economy through the railroad, and the things that go on rail and on ships and on aircraft now, you could have never foreseen the business model originally until the train or the ship or the plane existed. However, we think this is the sort of first mile leg. So when you want to send a package from here to America, you don't go and buy a boat. You don't go and buy an aircraft. You go to a company that's going to route your logistics across all of these different modes of transport and get it from your door to their door. And so we think the future looks a lot like that in space, that orbital locations will become destinations that you can post things to, ship things to, and you won't actually care which rocket, which aircraft, which boat it needs to go to get there. And so that's, I guess, our business premise. And so what we're doing at the moment is looking at the last mile connectivity, because we think fundamentally at the moment there is a huge amount of money going into rocket development. As your slide pointed out just before, the price is coming down. So we think that's going to be the fundamental step that unlocks the economy. Hopefully you're at the forefront of doing that as well. But once we get there, you're in LEO. Now how do we go to MEO? How do we go to GEO? How do we go to Lunar? And that's what Space Machines is all about. So I've sort of talked a bit about this premise, but it's probably worth reiterating. When you send packages and posts and things, you go to FedEx or you go to Australia Post. Now they run courier vans, they run all sorts of things to get you across the logistics network. And we think that's sort of where we're at in space. So we think the first mile transport is the rockets. Every rocket company we're talking to at the moment is increasing their capacity to drive down the economics of it. And so that's the first key thing, because we're not a rocket company. We have no ambitions to build a rocket, but we're very much leveraging off the curve of the economics changing. We think from there, there's going to be a bunch of vehicles that are going to be built around last mile delivery, but also in-space depots. So much like you see freight forwarders here, your packages come from the US to Australia, they go to a depot, they go to an airport, and from there they change mode of transport to enter your address. So we're seeing the rise of the sort of commercial space stations and depots at the moment. There's probably 3 or 4 major ones being built. And finally, we think the future looks like a sort of software and experience layer over that, because the logistics routing, it's invisible to the customer. You never think about that, and that's the way it should be. Customers should say, I want it delivered to low lunar orbit at this thing, here's my price, here's my package, off it goes, kind of thing. You should never need to think about the regulators or the rockets or the last mile delivery. So we think in the future it looks like that. And so that leads me to our vehicle, Optimus. So this is a vehicle we're building at the moment. We've got a sort of a prototype launching on Gilmore soon. And we have a much larger vehicle that's around the sort of 270 kilo mark that's being built to launch on SpaceX next year. And so how does this model work? So basically, for now, our customers, we aggregate, much like a courier van, we aggregate the packages into our orbital transfer vehicle. We put the whole thing on a rocket. The rocket takes us to any destination in LEO at the moment, and our vehicle takes us the last mile. And the vehicle we're designing at the moment is really, it's got quite a high delta V, so it's actually designed to go from sort of low Earth orbit up to low lunar orbit. So it gives us quite a wide range of orbital destinations we can get to, including sort of, taking payloads to GEO, taking payloads to lunar, but also doing, orbital inclination change is quite hard, delta V, but we do have some ability to orbital delta V on that. But our vehicle is quite versatile, so we're going to leverage off the first mile transport to take our customers to the last mile. And probably what I should say, at heart, Space Machines Company is a transportation and logistics company, but once you have a vehicle that has huge delta V in space, you start to unlock the in-space economy, in-space services, servicing spacecraft, maintaining spacecraft, delivery of packages between depots. We have a lot of customers at the moment who are hosted payload customers who want to get to space. So we unlock a whole lot of these other applications that we think once the in-space economy is really booming, everyone wants to do that. And I guess our kind of future vision, which is not that far off, is that our vehicles will be refuelable in space. So once we can, get refueled in space, our delta V can go to the moon and come back, and we move away from the capital cost of building vehicles to the operational cost of fuel. I'll just take a quick look at the vehicle itself for the techies in the room, which I guess is most of us. It's portioned into a lower bay of the spacecraft, which is mainly a propulsion module. It's designed for the ability to either carry electric propulsion or chemical propulsion. Certainly our first main mission, we're just flying a chem propulsion version. It basically has a bunch of avionics in the upper bay of the spacecraft, which flies it as a spacecraft. And then we have either a bunch of things like CubeSat dispensers, or we have a bunch of rings for larger spacecraft. And the baseline vehicle of Optimus will be able to carry up to about 300 kilos of payload across variable orbital destinations. And with that, I'll try and buy Andrew some time back, so I don't know if you want to do questions now, Andrew?
Yeah, we've got a minute or two for questions, so go ahead.
Any questions? Crowd is shy at this point in the morning. Evian.
Well, I was just going to ask about the type of electrical thruster that you're intending to fly, perhaps. Is it going to be Hall thruster? What's it?
At this point, the tech we'll baseline around is likely to be Hall effect thruster. Yeah, that's, I think, the most mature tech on the market at the moment from our perspective. I mean, we're watching a huge bunch of other developments and talking to many of them, but Hall effect thruster in our view seems to be about the right point in its evolution and price point. I mean, it's still quite expensive. I'd love them to be a lot cheaper, but yeah. Another question?
Yeah, I was just going to ask, so the plan would be to rendezvous with payloads coming up from Earth and then carry those up.
So certainly to start with, that's not our plan because it's quite hard. So I mean, what our plan is at the moment is to leverage the cost economics of large launches and be able to take small payloads to destinations that they can't access cost effectively. You know, if you have a 50 kilo satellite, you can either go on a small rocket, which is really quite expensive, so we can really beat those, but it's really leverage that. In the second stage will be just refueling in orbit, so that gives us the ability to go up in one orbit, refuel, and access a huge bunch more destinations. Ultimately, we'd love to get to the point of rendezvousing, because then it's you know, the economics of it moves to the price of fuel. You know, that's the kind of fundamental thing. But that's still hard tech, and there's a lot of companies doing it. But hopefully, in a few years.
Thank you. Thank you, Mark. Great to see the company.